Yeah, good afternoon, students. It's my pleasure to introduce in today's session that the hardware components in which we are discussing about this arithmetic logic unit. So, in the previous session, we had discussed about the hardware components which is related to this register files. So now we are going to discuss about the hardware components about this arithmetic and logic unit. So this is the today's classroom discussion topic on hardware components and arithmetic logic unit. So the today's lecture objective is that this session will develop the students' knowledge in understanding the method of connecting arithmetic logic unit to the register file in basic processing unit. So that is how this ALU is connected to the register file in basic processing unit. That is nothing but your CPU, how it is connected that. So arithmetic logic unit, ALU stands for that. Fine. So we are going to discuss about how this ALU is going to be connected to the register file. So if you take this, the top diagram, if you take that, so this is what we are calling it as the register of file. This is a register file, just we have seen that. So this is a register file we have. Okay, this is a single memory register file. Here we have the address A, address B, okay, and then address C, which is an input here, and these are the outputs here, which we are calling it as A. This is an output, that is the register file output, and this is the register file output, second register file output. So if this register file output is get connected to this arithmetic logic unit, so this is what we are calling it as an arithmetic logic unit. So in A is nothing but it is the input A point, input A, and this is in B is nothing but input B to this arithmetic logic unit. So how it is get connected? The input A in A is nothing but the output of register file, that is A, which is connected to this input of arithmetic logic unit, and the output of register file B is connected to a mux multiplexer B. So where this is nothing but we have a 0 bit and 1 bit. If we have a 0 bit enabled, that means the output of register file B is given as an input to the mux, and if it has an immediate value in the operand, then that is given as this mux input signal 1. So based on that, this mux output, mux B output will act as an input to the arithmetic logic unit as in B. Then it will perform this arithmetic logic operation is carried out in this unit, and whatever the output that ALU generates by taking these inputs in A and in B, that output will be given as this, what we are calling it as this input C to the register, so that we are going to store that output value as address of C. Okay, so this is how we are connecting these components. So the arithmetic and logic unit is used to perform the manipulation of the data. That is nothing but you are doing the arithmetic calculations, you are doing that. So it performs the arithmetic operations such as addition, subtraction, and the logic operations as like and, or, not, XOR operations will be carried out by this ALU. So conceptually, the register file and the ALU may be connected as shown in this particular diagram. So when an instruction that performs an arithmetic or logic operation is being executed, so the contents of the two registers specified in the instruction or read from the register file and becomes available at outputs A and B. Fine. So output A is connected directly to the first input of the arithmetic logic unit INA, and output B, which is a register file output. Okay, so B is connected to a multiplexer MUXB. So the multiplexer selects either output B of the register file or the immediate value in the IR to be connected to the second ALU input, that is INB. Okay, so that is if it is a register file output or whether we are providing the immediate operand value. So if it is an immediate operand value, so the mux will make use of this selection bit as 1. If it is a register file output, then mux will select 0. Based on that, so the mux will provide the second input value to the arithmetic logic unit as INB P. Just now we have seen that in this previous year. This is what we are doing here basically. If it is an immediate operand, the mux B will select that by setting the selection bit as 1, and that immediate operand value is given as input to arithmetic logic unit as INB. Otherwise, if it is not an immediate operand value, if it is a register operand input, then it will select that B register. The mux will select through the selection bit 0, and that B register file will be given as an input directly connected to the INBB, which is an input as acting for this ALB second input. Fine. So this is how it is doing the connection between this register file and arithmetic logic unit. So the output of the ALU is connected to the data inputs of the register file, so that the result of the computation can be again loaded into the destination register. So the output of this arithmetic logic unit is again connected to the data input C of the register file. Fine. So that stored again in the it will be stored again in the destination register file. Fine. So this is how the connection will be done. So this is one way how we are connecting the ALU with the register file. Now at this point you have to able to answer this reflection point 1 question. So what is the purpose of arithmetic and logic unit? Any students, are you able to specify what is the use of ALU, arithmetic and logic unit? Fine. I hope we have already familiar with this functionalities of arithmetic logic unit, which will help you in answering this question. So the lecture level practice problem is that you must able to analyze the method of connecting arithmetic logic unit to the register file, how we have connected that. Okay, it is very simple. Okay, so you have to draw the diagram and then you have to write one or two statements how the register file outputs are get connected to the ALU via a mux, so that one output of the register file is given as input to the arithmetic logic unit, and another output of the register file will be given to a mux multiplexer, and then the multiplexer will select either the immediate value or the register value as the second input to the arithmetic logic unit, so that after performing the arithmetic and logic operation, the result will be again stored into the processor registers. Fine. So this is what about how the arithmetic logic unit and the register files are get connected. So after completion of this today's session, so you must be able to analyze the way of connecting arithmetic logic unit to the register file in a computer system. Fine. So any doubts you have in today's session, students? So if you do not have any doubts, so please I request all the students watch these videos time to time and give your valuable feedback on these particular video lectures, so that in further coming sessions it will be improved a lot if you are able to provide valuable suggestions. Fine. Thank you one and all. So now I would like to close this today's session.